Hi everyone. This week we're talking about integrated reasoning, so we're going to be walking through an example of this type of question from the GMAT. Now there is no sample problems of these included in the written version of the textbooks, and so I have taken an example from the online practice questions of the official guide for GMAT Review 2017. I've included everything you need to know in this presentation, so you should be able to follow along and walk through the question with me. For this problem, the first thing we want to do is read what the question asks. So the sample I've chosen says the following. In New Zealand, the grape is a long-established crop, but the truffle, an edible fungus that grows on the roots of certain trees, became a commercial crop in the 1980s. The graph represents projected cumulative net income for grape and truffle crops through the end of the year in thousands of New Zealand dollars per hectare, or New Zealand $1,000 per hectare, for each of the first 11 years since planting. Cumulative net income is equal to total revenue from crop sales for the years since planting minus total investment costs over those same years. For each drop-down menu, select the option that creates the most accurate statement about these projections based on the given information. So then we can see we have a graph, and on the vertical axis we have New Zealand dollars and 1,000 New Zealand dollars per hectare, and across the horizontal axis we have the years since planting. And then you can see we have grapes and truffles as our two crops, and we have a growth pattern for each of those. So 3A says cumulative net income from truffles is least at the end of the blank year since planting, and 3B says if cumulative net income for grapes continues to grow at the same rate as in years 8 through 11 since planting, the cumulative net income from grapes for the 12th year since planting will be approximately blank New Zealand dollars per hectare. So if you want to take a closer look, I always do this before I answer a question. I pull down the two pull-down menus and kind of see what answer I'm looking for. So if you pull down the first pull-down menu, you'll see that your choices are 3rd, 5th, or 7th. And if you pull down the second pull-down menu, you'll see that your answers are 4,000, 7,000, 10,000, or 13,000. So this gives you not only the format that you're looking for, but it gives you some possible answer choices, just sort of gets you in the right frame of mind, I think. So I prefer to always review my possible answers before attempting to answer the question. So first, let's look at 3A and see if we can answer that. Again, what 3A said was cumulative net income from truffles is least at the end of the blank year since planting. So here's our graph that was provided. We are looking for where the cumulative net income from truffles was least. So we're going to look for the lowest point, and we can see that that point falls above the number 5. So it's asking at the end of the blank year, and if we go back to our original question, it says that the numbers are showing at the end of that year. So we are looking for the number that's least, that is at the end of the 5th year. Now, if it had been the other way around and the markings actually indicated the beginning of the year, then your answer would have been different. But in this case, we're looking for the end of the 5th year. That's where our number is least. We're looking for strictly the lowest number on our graph. For truffles, of course, so we want to make sure we're looking at the right line. Now let's look at question 3B. If cumulative net income for grapes continues to grow at the same rate as in years 8 through 11 since planting, the cumulative net income from grapes for the 12th year since planting will be approximately blank New Zealand dollars per hectare. So again, we want to go back to the graph that we have. We're looking at in years 8 through 11. So again, it's important to know where the end of one year is and where the beginning of the next year starts. So if we're looking at the growth in years 8 through 11, that's going to be the whole year of 8, the whole year of 9, the whole year of 10, the whole year of 11. So for our beginning amount, we actually want to look at the value above the number 7, because that's going to be the beginning of our 8th year or the end of our 7th year. And then our ending value is going to be the end of the 11th year. So we are trying to look at the average yearly growth through years 8, 9, 10, and 11, 4 years. And if we look at the graph then, so we can look at the beginning of the 8th year or the end of the 7th year, and we can see that our value is equal to minus 10. And then if we look at the end of the 11th year, we can see our value is equal to about plus 6. You don't have individual lines, so you can't see exactly that it's plus 6, but you can see that it's higher than the halfway point, visually speaking, but it's not much higher. So it's probably either going to be 6 or 7. When I eyeballed this, I thought it was 6, so I'm going with minus 10 and plus 6 for my two values. So now we want to find out what was the average growth per year. So we want to look at the difference between our value at year 11 and our value at the beginning of year 8. So the end of year 11, the beginning of year 8. End of year 11, our value was plus 6. Beginning of year 8, our value was minus 10. So 6 minus minus 10, or 6 plus 10, equals 16. So there was a growth of 16 during the years of 8, 9, 10, and 11. So now to find the average yearly growth, we want to divide that number by the number of years. Now at this point, it's easy to put in 3 instead of 4, because you're thinking, oh, the difference between 11 and 8 is 3. Well, it is, but we're looking at the growth during years 8, 9, 10, and 11. So that's actually 4 years. We're starting at the beginning of year 8 till the end of year 11. So year 8, year 9, year 10, year 11, 4 years. So when we divide 16 by 4, we get 4. We apply our labels back to our number, which it doesn't really matter what our labels are, because we're using the numbers on the graph. But what our labels translate to is that the average yearly growth between year 8 and year 11 is New Zealand dollars 4,000, or 4,000 New Zealand dollars per hectare. So now let's look at the question again. If cumulative net income for grapes continues to grow at the same rate as in years 8 through 11 since planting, the cumulative net income from grapes for the 12th year since planting will be approximately what per hectare? So we're going to look at our graph again, and we're actually now trying to find the net income for the 12th year. So we need to take the value that we have at the end of the 11th year, which is 6, and then we need to add on our yearly growth that we've just calculated. So we're going to take 6,000 New Zealand dollars. We're going to add on the 4,000 New Zealand dollars that we calculated for as the annual average growth, and we're going to get New Zealand dollars of 10,000. So if cumulative net income for grapes continues to grow at the same rate as in years 8 through 11 since planting, the cumulative net income from grapes for the 12th year since planting will be approximately 10,000 New Zealand dollars per hectare. If you have any questions about this problem, any other integrated reasoning questions, or any questions at all, please post to the Ask Your Instructor thread or send me an email. Thanks.